It's the ideal opportunity for an inestimable commemoration. NASA's Sol rover arrived on the dusty surface of Mars precisely 21 years ago, upsetting our insight into the red planet. As a matter of fact, the golf truck-sized wanderer was initially entrusted with looking for hints of water on Mars. Also, it eventually satisfied its mission decisively. From that point forward, we've discovered that the ruddy, gleaming heavenly body was in no way, shape, or form generally as extremely dry as had for some time been accepted. But the Sol mission also had a series of rather upsetting incidents in store. Sadly, contact with the test was abruptly lost in March 2010. And since NASA specialists couldn't restore the connection in the period that followed, the mission had to end the next year. Luckily, Sol was not alone in exploring extraterrestrial worlds. Its sister test, Opportunity, was built in the same way and would continue to look at Mars under the magnifying lens until June 2018. All beneficial things come in threes. When NASA's Sol and Opportunity tests landed on Mars on January 4 and 25, 2004, they did not land in the conventional sense. Rather, they initially bounced across the planet's surface multiple times in a heap of airbags before finally coming to a stop. And while the tests had left Earth on June 10 and July 7, 2003, NASA specialists had given them a very invigorating task. Could it be that Mars, which today is a perfect representation of a seemingly dead and cold planet, once had water? Since the Mars Global Surveyor and 2001 Mars Odyssey space tests had already revealed obvious hints of a previous lake, the specialists chose to select the corresponding area in the Gusev crater as the landing site for Sol. Opportunity thusly got very close and personal with a little cavity in the Meridiani Planum, on the opposite side of the planet. And assuming everything had worked out as expected, the mission would have been over after around 90 days. Luckily, however, not all things go as planned. Eventually, while the initially anticipated mission length was only 90 sols, Mars days, both tests were to exceed this target range by a long shot. A short explanation: 1 sol is equivalent to 24 hours, 39 minutes, and 35 seconds. But Sol eventually covered in excess of 2,200 sols rather than the designated 90 sols, meaning that it was able to travel altogether more meters and take an astonishing number of pictures. Communicated in sols, this means that the rover moved a total of 7,730 meters across the Martian surface, sending in excess of 156,000 pictures back to Earth. Yet, the rover's scientific work was not neglected either. Sol took nearly 370 measurements with the APXS, Alpha Proton X-ray spectrometer, and 933 measurements with the so-called Mossbauer spectrometer, which was able to analyze Martian material without destroying it. As already mentioned, Sol was not tied to a fixed location. Rather, with its 6 independently driven wheels, it was capable of exploring the Martian surface in a mobile way. In addition to the various cameras and spectrometers, the test was also equipped with a swiveling arm and a rock magnifying lens, as well as an instrument that allowed it to brush and drill a few millimeters into rock surfaces on the path of Martian water. While most of us would likely need a short breather after an excursion through space lasting a while, Sol began sending the first high-resolution color pictures from Mars to Earth not long after its airbag-supported landing. What we saw was another Martian no-man's land sprinkled with reddish-brown sand and endless stones, which from the beginning could easily be confused with a natural desert. No less amazing, however, was the vivid color picture of the central part of the supposed Columbia Hills, captured from a distance of around 300 meters with Sol's panoramic camera. Yet, after the first pictures were taken and the first chemical and mineralogical tests had been done, an incident happened that generally seemed like an ominous sign. On January 21, 2004, NASA's ground team suddenly lost contact with Sol. It soon became clear that Sol's computer had failed and was continually rebooting because of a memory error. Luckily, the specialists were able to fix the issue quickly and resume normal operations. On February 6, the scientific focus of the mission, the search for past water, was also initially poorly blurred. The analysis of the first rock samples showed that they were basaltic in nature and showed no impact from the cool, wet past. Seeking the component hints of water elsewhere, NASA decided to send the rover to the Columbia Hills, which were over 2 kilometers away. There, the rover detected an exciting first sign. Spectroscopic assessments of a rock showed that it contained hematite, a mineral that can form in contact with water, among other things. However, the definitive water discovery was made on Sol 205, named Coulis. This special rock contained a distinct mark of the iron-rich mineral goethite, which contains water as hydroxide as part of its structure. Exceptional disclosure was something like one of the most certain signs of the presence of water on Mars. Opportunity recorded a similarly surprising find on the opposite side of the planet. Explicitly, Sol's sister test was faced with unfathomable blueberries at its arrival site, and in this setting, obviously, they are not delectable Martian blueberries, but little rock circles. These are again made out of hematite and were, to some extent, implanted in the layered stone of the hole edge or dissipated before it, from which the scientists inferred that they were framed inside the stone. This is pivotal, since additional examination showed that it contains hosei, a potassium iron sulfate hydroxide that ordinarily forms in a watery climate. What Sol learned about life on Mars? Sol then, at that point, gave himself to the undertaking of climbing Spow's slope and took another series of captivating all-encompassing pictures on an edge beneath the highest point. Further journeys to Mole Slope, Low Edge Shelter, and Silica Valley followed, where Sol caught a dust fiend, a unique air vortex around 34 meters in size. However, the Wanderer also had further outcomes as it continued looking for water traces. While SPE Sol had already identified a sulfurous material at Spow's slope in which water molecules were likely bound, the test experienced a stone with a high magnesium iron carbonate content. This came back down, since this forms in wet and pH-neutral conditions and disintegrates in acidic fluids. Sol had revealed an unequivocal sign that non-acidic water must have once soaked the red planet. In Silicon Valley, on the other hand, a sandy stirred-up region turned into the focal point of scientific interest. The thrilling thing about this was the reality that the sand being referred to comprised 90% silicates. And, generally speaking, such a concentrated silicate aggregation can only be formed under the influence of water, and it's even conceivable that the water from an underground aquifer was involved. That amounts to nothing other than that the locale being referred to could once have offered great circumstances for the development of life. However, the cutting-edge Martian environment is somewhat more blustery, as was demonstrated by the severe planet-spreading dust storm of 2007, which severely hampered the further mission of the two meanders. Consequently, under 9% of daylight reached the surface, and it took half a month before Sol and Opportunity were able to complete minor exercises again. And after Sol accidentally broke a stone with one of its wheels, examination of the stones inside revealed that it could also have come from a hot spring. A wanderer in a trap. The end of the Sol mission came when it entered a hibernation period to save energy, and another nearby dust storm later. Anyway, the absolute worst situation happened on May 1, 2009. Sol got caught in the extremely delicate free material of the West Valley and was now caught in a sand trap. To move the Wanderer out of its situation, the specialists recreated its stuck circumstance even on Earth. However, tragically, Sol could not free itself inch by inch. Luckily, in the same breath, it was still able to generate enough power to do further investigations, which permitted the sandy trap to be identified as a combination of basaltic and silicate-rich materials. Consistent with the proverb, a surprisingly good development. The Wanderer's entrapment ended up being an interesting opportunity. The composition of the surrounding surface layers demonstrated that fluid water should have been present here recently. This was the best way to make sense of why solvent mixtures, for example, ferrous sulfate, had been washed down such a long way, while non-solvent minerals like hematite and silicate stayed on the surface. Regardless of this, there was still the issue that the Wanderer was stuck, unable to push ahead or backward. NASA responded by launching a high-profile campaign called Free Sol, which allowed the public to participate in the rescue efforts. In the course of the assessments, the specialists arrived at the conclusion that Sol had broken into a pit filled with sand and covered by a firmer crust. Furthermore, 6 months later, things finally got serious. Tragically, the subsequent recovery attempt was not crowned with success. Only millimeters could be gained by the few leading commands, And during one of the rescue efforts, the right rear wheel of the Wanderer failed. The steadily declining energy supply and the approaching Martian winter did little to ease the situation either. And on January 26, 2010, NASA had no real option except to report the end of the vain rescue efforts. From that point on, the Wanderer was to act as a fixed exploration stage. Furthermore, it would likely have done so if radio contact with it had not been lost on March 22, 2010. Despite NASA trying different stunts to re-establish the connection until May 25 of the following year, Sol never responded again. This amounted to nothing less than the compulsory finish of the mission. Also, the last picture that Sol sent to Earth in February 2010 shows us once again an all-encompassing perspective on a piece of the 166 kilometers wide Gusev crater. As already referenced, its sister test, a potential opportunity, was an activity. The mission just finished after 14 years and 219 days on Mars when it couldn't be stirred from hibernation after a dust storm. The last opportunity pictures were taken on June 10, 2018, and they show us the faintly glowing sun in the Martian sky, which is simply being obscured by the oncoming dust storm. And now, we'll show you how you can obscure the faintly glowing Buy In button with your click, press approval, and subscribe with joy so you won't ever miss another video from us again. We'll see you soon.